Here's problem 1957. In part A, we have a meta-substituted molecule. Now, bromine is an ortho-para-director, and alkyl groups, just normal methyls and ethyls, are also ortho-para-directors. But what you should recognize is that one way to make alkyl groups is from the corresponding ketones, the phenones. So what we can do is imagine that we have this molecule here, and this could possibly come from a ketone, right, where we have a carbonyl right next door to the aromatic ring. And you see this guy here is a meta-director, so that's going to be your trick here. Don't always think just Friedel-Crafts acylation. Think about Friedel-Crafts alkylation. Well, the opposite of what I just said. Don't think about only Friedel-Crafts alkylation. Think about acylation as well. So now we can think about this guy here is the meta-director. So let's pull off the bromine. You don't want to pull off the director, and that will get this guy here, and then that can come from benzene. So in the forward direction, I would say start with benzene, okay? And then we'll make acetophenone with the usual reagents, an acid chloride, aluminum trichloride catalyst, and what we get here is propiophenone, and then, acetophenone, sorry, wrong molecule. And then we can brominate. And remember, for bromination, you need bromine and iron tribromide. And this will give us the correct meta-substituted molecule. Okay. Now, this is not quite the product yet. We need to remove that carbonyl. And if it's right next to the aromatic ring, we can do that with the Clemmensen reduction. That's, zinc. Sometimes we add mercury to that to activate the metal, and so we get metabromoethylbenzene. Okay, so that's the recommended procedure there. Same sort of thing in molecule B. Nitrogen is an ortho-para-director, and halogens are ortho-para-directors. But these two are meta, and so what we need to think about is that a nitro group is a meta-director. So we're going to think about this coming from nitro groups, because that guy right there is a meta-director, and we have halogen at the meta position. So that can come from nitrobenzene, and that can of course come from benzene. So the synthesis I would do for this is to start out with benzene, and I would nitrate this. Remember that when you do nitration, you need two reagents, sulfuric acid and nitric acid. So that will give you nitrobenzene, and I'll position that on the upper left-hand corner so it matches. And then we can brominate. Bromine in the presence of iron tribromide will give you the meta product. So we want to place the bromine here at the meta product position, and then what we want to do is reduce the nitro group. And we can do that with iron and hydrochloric acid to give metabromoaniline. Okay. In part C, this is a little bit more challenging because this right here is an ortho-para-director, and this is an R group, so it's ortho-para-directing. And so what you have here is a situation where neither of these is a meta-director, and you see these two group substituents are meta. Now, you have a choice to make. You could decide that this guy here here's your choice. You could decide that this would come from a nitro group, all right? And this would be correct in the sense that this is a meta director, okay? And then you could think, well, you know, you just stick on the ethyl group, right? You just stick on the ethyl group there. But this is has a problem associated with it, because if you treat nitrobenzene with chloroethane in the presence of aluminum trichloride, this reaction does not occur because it's too deactivated for the Friedel-Crafts acylation. So the better way of thinking about this is that this group, this molecule here, could possibly come from this molecule here, okay? And this would be correct in the sense, again, that we have a meta director, okay? So that could come from, let's just pull off the the aniline group. That could come from this guy here, which is called, I think I'm putting on too many carbons. Okay, that could come from acetophenone. All right, and you know, we know how to make that. So let's use this route here. So again, this is the meta director, so we'll place something on the meta position, which is what we need in our molecule. So the synthesis will be to take benzene, and like we saw in part A, I believe it was, treat it with the acid chloride and aluminum trichloride to give you acetophenone. Now, acetophenone can be functionalized. Now, we can't stick an amine group on directly. We have to first do a nitration. Okay, do a nitration. Oops, I keep adding another extra carbon. Okay, so now we have this molecule. It's a meta disubstituted benzene ring. And then there's more than one correct way here. You could reduce the nitro group, or you could reduce the ketone. So I'll just reduce the nitro group here to give the aniline. And then I'll reduce the acetophenone kind of part of the molecule with the Clemmensen reduction. Okay, zinc, HCl, and that'll give the target molecule here. Okay, so we don't have that anymore, do we? So let me erase that. All right, so that will be a synthesis for this molecule here. So that's 4 steps. All right. Okay, so that's how you do problem 19.57. I'll post this on YouTube, and I hope you